Okay, this is my next limit video. I completed 52 questions last 4 videos or 5 videos of limits. Sixth video. The next question, limit x tends to 0, x approach to 0, 2 over sine 2x minus cot x. Find the limit value when x tends to 0. To directly substitute x for 0, sine naught, 2 over naught, infinity. What is cot naught, infinity, tan naught, so 1 over naught, infinity. So meaningless pattern, then use any other format to calculate this limit value. Limit x approach to 0, 2 over, what is sine 2x, 2 sine x cos x, 2 sine x cos x, here minus cot, you can write the cot, cos over sine, tan reciprocal is cot is cos over sine, cos x over sine x, okay. Therefore, limit x approach to 0, 2 cancels, is simplified. So I take the LCM format, sin x cos x. Okay, then what happened here? Multiplied by cos x here. It's okay, 1 here minus cos square x. 1 minus cos square. So what is that? Limit x approach to 0, 1 minus cos square sine square over sine x cos x. Okay, then cut 1 sine, cut here, then sine over cos tan x. Tan x when limit x tends to 0. So what the answer? X tends to 0, tan naught is naught. Answer can be naught, answer can be infinity, answer can be naught. It won't come one of the 7 indeterminate form. That's why I showed the very first video, I explained 7 forms there. Infinity over infinity, 0 over 0, like that. Okay, the question that next problem 54. Question 54, limit x approach to 0, square root of 1 plus 3x square minus cos 2x over x square. Another important question, all well prepared model problems with expectation for the future exams in your provincial papers, term papers, final pure maths, advanced level paper, combined maths. One question, they are structured type, 25 marks. For one problem, you have to work nearly 100 questions, then only we are familiar with that and become easier when you find that such a problem. So what that? Put x for 0 and check. First you apply the given limit value and check what happens. Sometimes the straight answer there, number value or unique solution. X is 0, then 1, cos naught is 1, 1 minus 1, 0, over 0, therefore one of the meaningless pattern. Then what the idea, most question we use that conjugate method, right? Irrational parts, square root parts comes, we will remove the square root. Remove the square root, the way multiple by conjugate of the numerator, up and down, numerator and denominator. Therefore, limit x tends to 0, square root 1 plus 3x square minus cos 2x over x square into square root 1 plus 3x square plus cos 2x over what? Up and down, multiple by the conjugate of the numerator. Okay, so your first step, multiply above and below by the conjugates of the numerator. Then where we use this conjugate method factorization form. So limit x tends to 0, a minus b, a plus b form, that is 1 plus 3x square minus cos square 2x, it cos square 2x, right? And below no matter, because positive no matter, x square and square root of 1 plus 3x square plus cos 2x. Okay, now simplify that any trigonometric part. What is 1 minus cos square? 1 minus cos square sine square theta. If you are well in trigonometric identities, it becomes simple case. 1 minus cos square sine square. So sine square 2x here, right? Plus 3x square over x square into square root of 1 plus 3x square plus cos 2x. Okay, what happened here after? Now we simplify, you know, the special theory in the trigonometry, sine theta over theta pattern. Then how we write sine square x or 2x below x square, 3x square below x square. Now we write this x square separately for sine and that 3x square. So I show here, see this, sine square 2x over x square plus 3x square over x square. Is it okay? I write this x square separately for this and this, and the remaining part all into multiplication over square root 1 plus 3x square plus cos 2x. Okay, now rearrange limit x tends to 0. Now write the general pattern of sine theta over theta form. What is this part? Sine square, alright, sine 2x, then we need below 2x. Okay, but completely square. Then check actually sine square, okay, below x square, okay, there's a 4. There's a 4. To remove that 5, multiple the additional 4, right? Plus here what happened? X square cancel 3. Okay, let's check with you. Multiple 1 over square root of 1 plus 3x square plus cos 2x, right? Okay. Now what does? X tends to 0, sine theta over theta 1. So here 4, right? 4 into 1 plus 3. The other one, what? 1 over, put x4 0, here 1. You know, cos naught 1, right? So 1, 1, 2 here cancel. What the answer here? 7 is it? 7 over 2 is it? Or 3.5, right? 7 over 2 or 3.5, 3.5. The question 54. A very useful problem. Practice it, keep in touch. Important question for exam part. Next question 55. Limit x approach to 0 cos 4x minus cos 3x, okay, and minus cos 5x over x square. X tends to 0. X tends to 0. See what happens if you put x4 0, cos naught 1, 1, that is 1 0 there over 0. Okay, is it cos 4, cos 3, cos 5? See how to work this simplify method. Something I mean, this is into, right? Into. So that is into, right? Check wheel is into. That's why cost note is 1. Here 1, that side also 1, 1, 0. It's into multiplication. That's very important, right? Okay, now we see how to work this. Question 55. In a trigonometric part you have to apply, right? So here limit x approach to 0 cos 4x minus, that is what, if you know clear in the trigonometric identities, cos into cos form what? Cos c plus cos d, cos c plus cos d. If you take cos c plus cos d, 2 cos at the both write the half, again cos, subtract the both write the half. So check, can I write this form? Cos, to get this 2 as an answer, cos 8x plus cos 2x. Check value. After write and check whether it's okay. Below x square, check value this part. What is cos 8x plus cos 2x? The pattern of the cos c plus cos d. 2 cos, there's no 2. Therefore multiply by half, cos c plus cos d pattern. 2 cos, at the 2, 10, divide by 2, 5, okay? Subtract 6, divide by 2, 3, it's okay. Right, hereafter, change the trigonometric pattern. So if I write this limit x tends to 0, can write this 2 using LCM. 2 cos 4x minus cos 8x minus cos 2x, okay, over 2x square. Okay, I show that LCM down, 2x square. Still if you put x for 0, all one meaningless pattern, right? Meaningless pattern. X is 0, cos not 1, here 1, below 0, 1 over 0, the infinity, the answer. See any other trigonometric pattern you have to apply? 2 cos, now we change for the sine term. Try to change for the sine part, sine. If you put x for 0, what happened here? Cos not 1, there cos naught is 1. So 2 minus 1, 1, 0, right? Now we change for sine double angle formula. What is cos 2 theta? 1 minus 2 sine square theta. So change for sine every terms here. So therefore limit x tends to 0, 2. Now what is cos 4x? 1 minus 2 sine square 2x. Okay, and minus cos 8x is what? Double angle. 1 minus 2 sine square 4x. Okay, at last minus 1 minus 2 sine square 1 next, is it? Check value over 2x square over 2x square. Change everything into sine term, right? And now count the numbers. 2 minus 1, 1, 1, 1, 0, no numbers, vanishes. 1 times 2, 2. Here 1, 2 minus 1, 1, 1 minus 1, 0. Write the remaining part. Limit x approach to 0. Here what? 4 sine square 2x. Is it minus? 4 sine square 2x. Next minus minus plus. Okay, check value plus 2 sine square 4x minus minus plus 2 sine square x. Okay, so we have the answer for the sine 2 theta over theta pattern. Therefore, can I write separately for every part? 2x square here also 2x square, and here also 2x square, right? Now rearrange the form sine theta over theta 1, that pattern rearrange this question. So limit x tends to 0. Cut this 2, also cut this 2, or keep it and write it. What happened? Minus 4. Here sine 2x. Then we need below 2x all things square. Okay, sine 2 theta over theta pattern. And what happened? Any additional term? Any additional part? Here 4 is okay. Sine square okay. X square right. Actually 2 here, but 4. But here 4. Make that 4 as 2. Therefore, I multiply by 2 here. Check please, is it okay? 2, right? Multiply by 2. And similar, write the next parts. Same as general form of trigonometric limit sine theta over theta. And plus here 2 sine square 4x. Below then we need the 4x, but all things square. Now check with the accuracy. Sine square okay, x square okay, 16, but actually 2. Therefore what? Multiply by 8. Multiply by 8. And write the last one of the same pattern. Very long question, but easy problem, right? Here no matter, see 2 cancel, no matter. Sine x over x, its square. It's perfect straight theory of limit trigonometry. Now write the answers. When x is 0, x tends to 0. Minus 4 into sine theta over theta 1 into 2. Plus here the same 2 into, that form is 1 into 8. At last plus 1. So check what the answer is. Minus 8. Here 16. So 8 is a 9 answer. Check the answer is, if we simplify 9, positive 9, right? Very useful problem. So stop the video. You have to try before me, then check with my, after pausing this video, you can correctly answer. Next question 56. My target to work nearly 70 problem. Then no matter any other problem, all used already. Question 56, write this problem. Limit x approach to 0, 1 plus sine x minus cos x over 1 minus sine x minus cos x. So find the limit value. What happens if you put x for 0? Sine naught is naught, cos naught is 1. So numerator 0, denominator 0, everything one of the meaningless pattern. Yeah, if we change it to any other form, right? Sine x no matter, you can change the cos to sine, because we need the sine limit part only. Therefore, you change the cos, that angle, into sine part. Cos x 1 minus 2 sine square x by 2, like that. Also try if you clear 1 minus cos x. You can write for 1 minus cos x also, whatever you follow, that matter. So there is limit x tends to 0, 1 plus sine x. Can I take the, show the cos theta double angle formula in terms of sine? 1 minus 2 sine square x by 2, okay, over 1 minus sine x. What is cos x? 1 minus 2 sine square x by 2, 1 minus 2 sine square x by 2, okay. So what happened? Limit x tends to 0, okay. Now see, 1 cancel, sine x minus minus plus 2 sine square x by 2 over here 1 cancel, minus sine x minus minus plus 2 sine square x by 2 okay. I think further your trigonometric issue, what is sine 2 theta? 2 sine theta cos theta pattern, sine 2 theta, 2 sine theta cos theta. So sine 1x, 2 sine x by 2 cos x by 2. You can take something and simplify. So limit x tends to 0, sine x, then write sine x, 2 sine x by 2 cos x by 2, 2 sine x by 2 cos x by 2, okay, and plus here 2 sine square x by 2 over same method below, minus 2 sine x by 2 cos x by 2 plus 2 sine square x by 2. Now take the cancel, 2 cancel, cut the 2, and you can cut by that sine x by 2 also, cut the sine x by 2, 2 sine x by 2, cut therefore they have limit x approach to 0, for that the remaining part is what, cos x by 2 plus another sine x by 2 there, after cancelling one sine x by 2, here what, minus cos x by 2 plus sine x by 2. So complete, put x for 0. Put x for 0, sine naught naught, cos naught 1 is it, 1 plus 0, minus 1 plus 0. The answer minus 1. If you follow regular this pattern only, you can get the answer, clear solution. This is my 56th question. Next question, 56th problem, 57th problem. Limit x approach to 3, x approach to 3, square root x minus 2 minus 1 over sine pi into x minus 2. See an important question. The sine angle is pi into x minus 3, right? X minus 3. See what happens if x for 3, x tends to 3. Check that if x tends to 3, 3 minus 2, 1, 1 minus 1, 0. This becomes sine naught is naught. Therefore 0 over 0, one of the meaningless pattern. Therefore rearrange the form and get the answer. So wherever either use the square root pattern that we used multiplying this conjugate pattern. So multiple the numerators, conjugate above and below, go through step by step. So there is limit x tends to 3, Okay, square root x minus 2 minus 1 multiplied by what? Square root x minus 2 plus 1 over x minus 2 square root plus 1 into separately sine pi into x minus, it's like a theta, right? It's like a theta, sine theta. So try to get sine theta over theta pattern, that's become easy. So at the numerator, wherever we use this conjugate pattern, factorization form, a minus b, a plus b part, that is what? X minus 2 minus 1, is it? Okay. A square minus b square over x minus 2, here plus, therefore no problem, below plus comes, no matter, and the remaining part sine pi into x minus 3. Okay, so next part, so what is that? Limit x tends to 3, x minus 3, okay, x minus 3 over square root of x minus 2 plus 1, with the remaining sine pi x minus 3. Okay, now finally you rearrange before the answer sine theta over theta pattern, right? This form, sine theta over theta form. So how that? Limit x tends to 3, 1 over square root of x minus 2 plus 1 can be shown sine, write that sine theta form over theta. Is it okay? Check now, check the accuracy or any additional part to be removed out now. See, this is okay. This x minus 3 is shown down here, okay? It goes up a fraction over fraction. Pi is an additional part. Pi is an additional part. It's division for pi. Therefore, I multiple by pi here. So now check, write the answer. 1 over, put x for 3, 3 minus 2, 1, 1 plus 1, 2. And here what it is? Sine theta over theta form, right? When x is 3, 0, that means sine theta over theta here is 1. This is 1. That is 1 into pi, okay? Therefore the answer 1 over 2 pi, is it? Check that accuracy, 1 over 2 pi. Is it okay? 1 over 2 pi is the answer. 57 problem. Okay, next question number 58. Then you write the question. This is write this. If alpha and beta, are the roots of ax square plus bx plus c equal to 0, are the roots of ax square plus bx plus c equals 0, evaluate limit x tends to alpha 1 minus cos ax square plus bx plus c over x minus alpha, all things square. check this answer. So this is not a straightly limit, there's a quadratic equation. So I hope you, when you are the primary, that means when you come to the advanced combined maths classes, grade 12 lesson, quadratic equation, the only basic part. They say alpha and beta are the roots of the standard quadratic form equation. Ax square plus bx plus c equal to 0. The roots are alpha, beta, you know how to write, the roots are given. How to format the quadratic equation, roots are given. X square minus sum of the roots into x plus product of the root, is it? X square minus sum of the root into product of the root. So can I write this form before I go to the answer? So you can write this ax square plus bx plus c form. I can say how ax square plus bx plus c equal to what? X minus alpha. Is it okay? X minus beta. Right? Is it okay? The roots are given. How to rearrange the quadratic equation? No, this is wrong. Why this is wrong? See here, ax square. If you multiple, no ax square, only x square only. Therefore, no a. So we write a into. If you learn theory class, you might did. You know this way how to write the quadratic equation. Roots are given. So a into this. Okay. Now we come to this part. Limit x tends to alpha 1 minus, write this, cos ax square plus bx plus c is a into x minus alpha into x minus beta. Okay, very important step. Over x minus alpha square. So what happened if you straightly write x for alpha? What happened x for alpha? A alpha square b alpha plus c, that is 0. A alpha square plus b alpha plus c is 0 because of alpha is a root, same as a beta square plus b beta plus c are 0, right? So cos 0 1, 1 minus 1 not, below also not. That's why this format. Okay, now change, that's all the quadratic equation part. Now change to your trigonometric pattern. You know that 1 minus cos double angle form. Try to write the double angle pattern. Got that cos 2 theta, 1 minus 2 sines. We work many times this expression. So can I write this one? Limit x tends to alpha. What is 1 minus cos? What is 1 minus cos? 2 sine square. 2 sine square this a into x minus alpha into x minus beta. Okay, over 2 half angle, half of that. Angle is half, check will you. Angle is half of that. Angle is half of that, right? Over x minus alpha square. You can't add this 2. This is for sine coefficient. That's the angle too, right? Okay. Now rearrange the form. Sine 2 theta over sine theta over theta pattern, trigonometric part. This completely is the angle, right? It's completely act as the angle part. So write general form and try to vanish any additional parts. So limit x tends to alpha to what is that, sine a into x minus alpha into, there is x minus beta, okay, x minus beta over 2 sine theta, then you need over theta, right? So first you write this part, a x minus alpha over 2 x minus beta, everything divided by 2 sine theta over theta pattern. But here square, therefore can I write completely square? You need the square, right? You need the square part. Here square, there square part you need it. Now check any additional values available to when you remove it by using the division or multiple. Try to remove it, try to remove that part. Sine, see this 2 is okay. Sine square, that is okay, right? What happened below? Here a square, there's no a square, therefore remove that a additional a square. How that I should write here 1 over a square, so a square cancel, okay? X minus alpha square, okay, the original problem, right? X minus beta square not available, therefore that also is multiple x minus, I show the green color, the additional parts, okay? And this 2, 4, this 2 becomes 4, no 4 there, therefore to divide this 4, is it check will you? Now see this is the expression final part. Now go to the final value is what? 2 into, this is 1, okay, this is 1, and a square, put x for alpha, don't miss that, x for alpha, alpha minus beta, alpha minus beta square over 4, cut the 2, is it okay, check will you the answer, a square into alpha minus beta square over 2. Check the answer, a square alpha minus beta square over 2. And the important question is some sort of that using the quadratic equation idea and connect with that. Okay, next question 59. See problem 59 and the useful question, limit x approach to pi by 2 1 minus sine x over 4x square minus pi square. See how to find this when x is 90 degrees or pi by 2, x tends to pi by 2. Rearrange that form. For every question there are so many methods, right? You decide this so easy way you can use that pattern. 1 minus sine 4x square. If you put x for 90, what happens? Sine 90 is 1. 1 minus 1 is 0. And here also here pi square over 4 cancel, pi minus pi by that pi plus pi, that also becomes 0 answer. So no use of direct substitute. Okay, there are so many. I will explain the both, you can work one of that. I'll show one method. See, first step where you multiple above and below by 1 plus sine x, okay? Multiple the numerator and the denominator by the 1 plus sine x first. So what happens if you multiply 1 plus sine and numerator, 1 minus sine, 1 plus sine, 1 minus sine square, that is cos square, that is cos square. Below 1 plus sine, so no problem when you use it trigonometric or any other limit theorem, okay? So check with this my method, limit x tends to pi by 2 1 minus sine x into 1 plus sine x over 4x square minus pi square, multiple below also 1 plus sine x above and below multiple. Okay, now say limit x approach to pi by 2, 1 minus sine x, 1 plus sine x, 1 minus sine square x over 4x square. You can factorize 4x square minus pi square, 2x minus pi, 2x plus pi, 2x minus pi, 2x plus pi, factorization, right? And here 1 plus sine x. Okay, so next step, limit x tends to pi by 2, x approach to pi by 2. What is 1 minus sine square cos square x? Cos square x over 2x minus pi, 2x plus pi into 1 plus sine x. Okay, so now see what happens if you put x for pi by 2. Cos 90 is not. Cos 90 not. Below the same, sine 90 is 1, 1, 1, 2. So here note, still this becomes what we call the indeterminate form, right? You can't solve it, right? So further simplify. See the method. Limit x approach to pi by 2. Can I write the cos x is cos x into cos x? Cos x into cos x over 2x minus pi, 2x plus pi, 1 plus sine x, right? 1 plus sine x. So why I mentioned cos square is cos x into cos x. Now I am going to change by sine trigonometric theory. Limit, see that, limit x tends to pi by 2. Can I write this 1 cos x? What is cos theta? Sine 90 minus theta, right? Sine pi by 2 minus x. Okay, then over you need the pi by 2 minus x. Pi by 2 minus x. Therefore, can I take somewhere here the 2 out? I take the 2 out, I take the 2 out, minus 2 out, check will you? For this bracket, check this bracket, I took the minus 2 out, then this becomes minus pi, okay? This arrange is okay, right? Arrangement is okay. And into other part, no matter, cos x over 2x plus pi into 1 plus sine x. Now use the limit theorem. See here, sine theta over theta 1, here 1, here 1, right? 1 over minus 2, here put x 490, okay, x 490, pi by 2, 2 cancel, pi 2 pi, and check here, sine 91, 1, 2, what the numerator, cos pi by 2, 0. There, whatever below, no matter, the answer is 0. Answer is 0. To get this answer in this method, this idea very important. This idea is very important. Sometimes you don't have the idea like that, the exam situation. Therefore, I explain another method also. You can apply that pattern. You can complete the same answer. That is method 2. With the limit, we decide the substitute method, right? With the limit, we decide a substitute method. Cross multiple 2x tends to pi. X tends to pi by 2 means 2x tends to pi. Take the pi other side. 2x minus pi. Put u. Second method, let 2x minus pi is u. 2x minus pi is u, right? Then if you use any substitute method, all the entire question should change to the u format in terms of u. So when x is pi by 2, when x is pi by 2, u is 0, is it? U is 0, okay? Next one, 1 minus sine x. What is x here? We can say pi plus u divided by 2. For check value, what is x equal? Pi by 2 plus u by 2. For that, sine for x equal pi by 2 plus u by 2. That is sine 90 plus theta pattern. Convert to x. Sine 90 plus theta cos theta. Below also you write for the x in terms of u and complete it. Can go to the answer. It becomes 1 minus cos u by 2 something. Yeah, 1 minus cos u by 2. Again change the cos part into 1 minus 2 sine square theta by 2. Cos comes again, you change to 1 minus 2 sine square theta by 2 properly and remove the additional part. You can go the same method, right? So try will you. The same idea, answer becomes not, okay? This is my 59. So that's the most formally the students using that pattern. I shown a different method here. Next question 60. Problem 60. Limit x tends to pi by 3, and the very important question, tan x minus root 3 over cos x minus sin x by 2. Okay, when x tends to pi by 3, what the answer of this? Check will be whether it's direct substitute by that. You know that tan pi by 3 is root 3. Tan 60 is root 3. Tan 60 is root 3. So what happens if it's a direct substitute? Root 3 minus root 3 0. Will also cos 60 half, sin 60 root 3 by 2. Cos 60 half, that is sine pi by 6 also half. So one of the meaningless pattern, right? You can't convert that form, okay? Therefore use any other form. We change the tan is what is tan. Sine divided by cos is tan, right? Sine divided by cos is tan. And below here cos, but they are sine. Now we write the cos as sine pi by 2 minus x. Sine pi by 2 minus x, sine 90 minus x is cos x. Then we have format, okay? So continue, they're all trigonometric part. Finally only you have to apply the limit theorem, okay? So very first step, very useful question for the exams. Write the tan as sine x over cos x. Okay, tan is sin x over cos x, okay? What is root 3 tan pi by 3? Root 3 is tan pi by 3, okay? Root 3 actually tan pi by 3. Alright, that also minus sin pi by 3 over cos pi by 3. First steps are very important. If you miss the first step, you can't go to actual solution within short period, short time. As I mentioned, what is cos x? You write sine 90 minus x, right? Sine 90 minus x minus sine x by 2. Okay, so hereafter limit x tends to pi by 3. I show once again sin x over cos x minus sin pi by 3 over cos pi by 3 What is sine 90 minus x cos x? Okay. So why I shown this sine 90? They are also sine. So sine c minus sine c pattern. Sine c minus sine d pattern. What is sine c minus sine d? 2 cos. At this 2 angle, write the half. Very important, don't misuse. Write properly at these 2 angles. At these 2 angles and write the half, right? Divide by 2. Sine c minus sine d. Next one. 2 cos at the 2 write the half. Other one is sine. Subtract pi by 2. Sine pi by 2 minus x by 2 half divide by 2. Refer your sine c minus sine d pattern. Refer that. So hereafter limit. Very useful question. More chance for incorrect form. If you misuse, problem is wrong. So follow carefully the step by step. Next we use this LCM pattern, multiple here, multiple there. Using the LCM pattern, simplify that. Sin x cos pi by 3 minus cos x sin pi by 3, okay, over, write the LCM, cos x cos pi by 3. There's a 2, I write the 2 below down here, I write the 2 here, right? Now properly simplify that one. Cos half, what is the angle inside? Pi by 2 minus x plus x by 2. What is minus x plus x by 2? That is minus x by 2. So cos half into pi by 2 minus x by 2. Okay. The same, write the other one, sine half, what is that, pi by 2 minus 3x by 2, is it? Check that, minus 3x by 2, right? You can view this video, right, properly, right? Now you know, here x tends to pi by 3, x tends to pi by 3, okay? Sin x cos pi by 3, sin x cos pi by 3 minus cos x sin pi by 3, what is the form? Sin a cos b minus cos a sin b, is it? Sin a cos b minus cos a sin b, that is sin a minus b, right? So a lot of trigonometric part. Limit x tends to pi by 3, but that sin a minus b, can write sin x minus pi by 3, okay, sin a cos b minus cos a sin b, okay, over, alright, you know cos pi by 3 is half, cos 60 is half, half and this 2 is cancel, okay, therefore cos x remaining, the remaining part, cos, we can take the half inside of the denominator, pi by 4 minus x by 4, that pattern, pi by 4 minus x by 4, if I multiply the half inside, okay, cos pi by 4 minus x by 2, okay, the same method you can write, sin pi by 4 minus that pattern, sin pi by 4, take the half out, sin pi by 4 minus 3x by 4, right? Sin pi by 4 minus 3x by 4. So you have to show this very careful, important problem. If you miss one step, difficult to search again. You have to cut it all and do it again, otherwise. Okay, now what? Limit. Still this is one of the meaningless pattern, right? X tends to pi by, is no problem. This is no problem. Cos 60 is half, cos 60 is half. Therefore, now we rearrange the general pattern of the sine theta over theta pattern. See, sine theta over theta forms sine theta over theta pattern. Can I write the x minus pi by 3, or if I take the 3 out, something pi minus theta, this form sine theta over, the same here, see, should, what we use here, same should be shown here also, the properly we check that, the idea, right? See, can I take this sine, I take this 1/3 out, or 3's if I take out, or I say the minus out, minus pi by 3 minus x. I take a minus out, right, over cos x. Oh, I write last, I write here at last, that one. Now write the sine part, that's sine also. Sine. So I try to show this pi by 3 something, pi by 3. Therefore, I won't take something out. Any method you can, sine theta over theta pattern, we'll write that form. That's the idea in this question, right? So can I take this pi out, what we call the pi by 3, see that pi by 3 minus x. Pi by 3 minus x form. Or take here what pi by 4, take the pi by 4 out, sine pi by 4 minus that pattern, pi minus form. Here, take the 4 out, see, take the 4 out, 1/4 out, check will you, pi minus 3x, okay. I took the 1/4 out, right? Sine pi minus 3x. So additional part what? Cos x into cos pi by 4 minus x by 2. Very useful. This I am showing, I'm explaining slowly. I am showing this. Try to identify this pattern. Is it everything okay? Is it okay? Yes. Okay. So I took the 4 out, okay. Now I change to sine theta over theta pattern and try to rearrange the additional form. Is it okay here? Pi by 4, right? Okay. That's everything okay, right? Now see, you know sine minus theta minus, okay? Extends to pi by 3. Here I write sine pi by 3 minus x, then below what? Theta, pi by 3 minus x, sine theta over theta form, right? And right below this is also same as the sine theta over theta. And you should remove some additional part by multiplying or dividing. Yeah, 1/, what is sine 1/4 into pi minus 3x, then over what? 1/4 into pi minus 3x, okay? And already we have this 1/, cos x cos pi by 4 minus x by 2, right? Now I leave a space here to show the additional part to be cancelled. Now check the additional part. This is okay, that is okay, this is okay. These parts are additional part. Check how this happened. We have already the x minus, right, pi by 3, see this form. Here 1/4, no 1/4 in the problem, no 1/4. Here is okay, sine. Additional 1/4 is additional part. Therefore, to remove the 1/4, I write how this form. 1/, is it 1/4 like this? Okay, then now it is cancelled, right? And now see what happened. This pi by 3 minus x. If I take the 3 out, if I take the 3 out here, if I take the 3 out, this becomes pi by 3 minus x. It's both are same, right? It's both are same. Take the 3 out, then pi by 3 minus x. So take a 3 out, this 3 also additional part. The 3 is the additional part, other parts are cancelled. So can I say a 3 over, check, will you properly check that? Stop the video, recollect that one, how I am showing this. Take the 3 out, 3 over 4, here pi by 3 minus, so cancel, this pi by 3 minus x. Pi by 3 minus x cancel. Remaining 3 over 4 is an additional part, that's why I simplify like that. So everything is okay. Now write the limit value. There's a minus here, sine theta over theta 1. 1 over that is 1, okay. And that is, can I take the 4 up? 4 over 3 into, go there, 1 over, put x4 pi by 3, cos pi by 3 half, cos pi by 3 half, into what? What is pi by 4 minus here, put x4 pi by 3, pi by 6. What is pi by 4 minus pi by 6? 45 minus 30, is it? Okay. Pi by 4, put x4 pi by 3, pi by 4 minus pi by 6. What is that here? 12, pi by 15, this is 3, 12, here 3 pi, here 2 pi. So what is that? Pi by 12, is it? Cos pi, check value, is it cos pi by 12? Cos pi by 12. This part cos, check is correct, check value cos pi by 12. Okay. This pattern cos, put x4 pi by 3, so pi by 6, 45 minus 30 is 15, pi by 12, okay, that's right. Now what happened, further simplify the answer, there's a minus value, So what that 2 goes up, 8 over 3 cos pi by 12. Check value is a minus answer, is it? Minus, there's a value for that pi by 12. Check value properly, this is okay by, oh, I missed this x by 4, is it? Check value x by 4. Check that I multiply the 2 here, x by 4, check value x by 4, that's why. X by, as I said, very slowly you have to work, we misuse problem. So x by 4, yeah, my method is wrong, the final answer wrong, here value not that. Check value what that, yeah, for pi by 4 minus what is put x4 pi by 3, pi by 12. Pi by 12, is it? Check that. So LCM is 12, so here 3 pi minus pi, 2 pi by 12, pi by 6, cos pi by 6, root 3 by 2 here, very important. Root 3 by 2, a useful question, very long problem. Root 3 by here, pi, x by, I missed that, x by 4, check will you. So therefore the answer is to 4 go that side. What is that? Minus 16 over 3 root 3 is the answer. Okay, very useful question. So I complete 60 problems. I target to 70 problems and the video I expect. So keep in touch. Take full opportunity of my this video series.